Hey guys, going to do a quick update on the status of my Quenchant warming tank that I've been working on for the last couple weeks or so. And before I made this video, I've actually made a couple of other updates for my shop where I briefly mentioned some of the progress and setbacks I've been facing with this project. However, I'm not sure if those will be uploaded at the time of this update, if I upload them at all. So I'm going to go ahead and possibly repeat some information here just for the sake of thoroughness to keep you guys up to speed on what's been going on here and some of the things that I've had to do in order to accomplish my goals. Now I've already made kind of an overview video talking about the scope of the project, what I hope to accomplish, as well as kind of a mid-progress video where I talked about persistence in knife making, based mostly on the issues that I was having with this and just the numerous attempts I've had to make to meet my goal in getting this sealed up watertight. But I am very pleased to announce that I finally met that goal with much persistence and much labor. So persistence does pay off, and I'm very happy that I stuck with it and was able to meet my goal with this project, up until now anyway. Whether or not we'll have any other setbacks through the remainder of this project until we get it into service is yet to be seen, but I believe I've surpassed the most difficult portion of this, so I'm very happy about that. Now, just to talk a little bit about the specific setbacks in that solution, what had been happening was that as I had this in its final assembled state, as you see it here, which is not including the thermostat or some other portions yet. This is just the portion of the water testing to make sure it's watertight. As I reached this stage, I had yet been unable to achieve complete water tightness. Whether it was a steady trickle or a very small pinhole leak. Both conditions were unacceptable for this type of project. Even the smallest leak for me was unacceptable, since I do plan eventually to put some fairly expensive quenchant oil in here, and I really don't want to have to waste that if I can help it. So I did need to make multiple attempts in making sure that this was sealed up. And kind of the process I went through just in trying to safeguard from the issue. I did this in two portions. Here's a spare flange that I had just in case there were further issues with this one that prevented it from being used any further. But what I would do, I'll show you the flange in a moment in its completed state on that one. But I would prep this for the installation of the flange that the heating element screws into. I would drill all of the mounting holes necessary, caulk around all of those holes, and seal the flange to that to where it would hopefully be watertight. I would then install the heating element complete with a rubber gasket to prevent it from leaking. And then I would fill this up once everything had cured and set with water up to the top of this rim here, just to make sure that there wasn't any water seepage at this stage, because once that 4-inch pipe is installed, it would be almost impossible to make any further modifications inside, whether it was tightening bolts, removing them, or caulking any additional surfaces. Because I really can't fit my arms into that pipe, much less all the way down to the bottom. So if that part failed, there was really no point in continuing on to the installation of the tank portion. But once I was satisfied that the base was watertight and complete, I would then apply some PVC primer and cement to this portion here, as well as to the inside of the PVC drain pipe, which is a 4-inch Schedule 40. I would then put the pieces together and let that set up before I tested it with water again. But unfortunately, with each attempt that I made, whether or not I was applying the glue liberally enough or just thoroughly enough, I usually had 1 or 2 very slight pinhole leaks, which again was unacceptable. And I further tried to mitigate those issues and remedy the problem by applying some either siliconized based caulk around the edges here where the pieces met, or even a rubberized sealant. Tried a couple of different adhesives and sealants in an effort to perhaps prevent that water from continuing to push out. Unfortunately, whether I just didn't leave it long enough to cure, or if it just wasn't, if the adhesives just weren't good enough to seal that, I still had some water protrusion issues. So I was about to kind of throw in the towel, or at least make one final attempt, when I was at Walgreens the other night and found the product called Mighty Putty, and kind of caught my attention, so I checked it out, saw that it was suitable for PVC as well as sealing leaks, even in a pressurized system, I believe. So what I ended up doing was purchasing that product and applying it much the same way I did the adhesive in the past around where these joints met. Let that cure up, water tested it again for a period of about 24 hours just to make absolutely sure that no water whatsoever was still leaking through. And I'm very happy to announce that I finally achieved a watertight seal that I was looking for initially. So we are ready to move on to the next phase, which is the installation of the thermostat and trying to troubleshoot that in a manner that it will be able to control the inside temperature of the oil. And just to show you the installed flange, we do have quite a bit of excess caulk around there, and then we have the element screwed in, so that is watertight. And I'm originally thinking about using those bolt heads, which do go all the way through, if you could see that, as kind of a heat sink or a thermal conductor, in order to hopefully transfer some of the inside temperature, if not all of it, from the oil to the outside in an effort to actuate the thermal disc on that thermostat, which once it reaches a certain temperature will open a relay contact, discontinuing current to the heating element. And hopefully by using that bolt head as a thermal conductor, I can effectively operate that thermostat and keep the oil at a somewhat consistent temperature for when I'm warming it to use for my quenching and my heat treating. Now, if that is not enough to conduct enough heat through to operate the thermostat, I may end up getting some aluminum or some copper probes of some kind and installing them somewhere on this pipe by sticking them through the pipe, and again applying some of that epoxy-based putty to seal that, but hopefully that will give a better thermal conductivity for operating that thermostat, which normally operates on a metal encased water heater, which does transfer the heat quite a bit better and is a much more accurate gauge for the inside temperature of the water, which in this case will be oil encased in PVC, which is not so much a good thermal conductor to use that thermostat as it normally would be, if all that makes sense. But I think we've at least surpassed the hardest part of this, which was getting it watertight. That's definitely one of the more important parts. If all else fails, I can simply just wire the element directly with an on-off switch and just monitor it with a thermometer as it gets up to temperature and cut the power myself. But I would like to make it a little more automated if possible. So that'll be the next phase of this project, and hopefully we'll be able to figure something out there. And as usual, I will keep you updated. I just wanted to give my little success story with this phase of the project, and hopefully it will continue to go as planned, so please stay tuned for further updates as I get time to work on this, and then I'll make a final video in much more detail going over the various aspects and materials used to create this warming tank. So as always, thanks for watching. I'll talk to you guys later.